Hello and welcome to STEM in the Box instructional video. In this video we're going to show you how to test the outputs of eBot using eBot app. So the first thing you need to do is plug in the USB cable and power the robot on, which you do either by putting in the power plug or turning it on if you've got the Pro. Excellent. Okay, so second thing you need to do is open up eBot app, and you should have a fresh copy of the firmware installed, which we've shown you how to previously do. Okay, so we press refresh list and that will populate the COM ports up here. So it's on COM 6. So we want to connect. Great, it's connected, goes green, and it's telling us that the firmware is version 1.36. That's on the robot. So in a previous video we've shown you how to test all the inputs, so we've done all that, and that's what all this data is on the over on the right hand side, so we won't need to be looking at that just now. So let's start with the LEDs. So if by default the firmware has the front two LEDs and the LEDs for the line sensor on 50% red. So let's turn them all on white so you can see they go white. Let's turn them off. So we can select here also to give them individual colors. Let's select all and let's make it fuchsia, and we can send that. So it does that. Great. So RGB, when you're programming in Scratch or Arduino, you'll need to be using the RGB values. We've set it up here so that it's 0 to 100 for red, green and blue. And you can also select the brightness. So let's select, say, 80% brightness. And let's make it blue, which means that we would set the green to 0 and the red to 0 and then go set, and there we go, they're blue. Great, so they all work perfectly, and of course you can address them individually by their number when you're programming. So they all work perfectly. Let's turn them all. Yes, let's just leave them the way they are. Okay, great. So the next output we're going to test is the claws. So that was on the LED tab down the bottom there. So these are your outputs: wheels, claw, and LEDs. So we've tested the LEDs. Let's go and test the claw. The Pro has the claw and the crane for up and down. The Junior just has the claw on the bumper, and that's it. So if we put in open 100% in the box there, so okay, so that's 100% open, and then if we go to 0% open, it closes all the way. Great. Okay, so what you can also do, if you like, is for servo 1 and servo 2, you can actually modify the range, which is basically the same as offset. So if I wanted it to go to, say, 800, this is actually the pulse, and I hit sweep. So you can see now that it's not coming in anywhere near as far. So I may want that, or I may not. So let's put that back to 500 and go sweep. And it's back where it was. This sort of sets the maximum and minimum positions, if you like, of each of the servos, which can then be called in Scratch or Arduino using our libraries. If you want to send that to EEPROM, you have to press the set button. So that's what the set button is. It sends it to EEPROM, which is permanent non-erasable memory, non-volatile memory on the eBot. So in other words, it remembers it when you program it. Great. So the servo's claws work perfectly. Let's go and test the motors. So we'll go to wheels, and to test the wheels, we will invert it so that we don't have the robot running away on us. So let's press the big blue button up there. Forward, backwards, stop, left, correct, stop, right, correct. Now, when I hit the stop button, sometimes the motors will creep. If the motors creep on the stop command, you will need to put an offset in there. Positive is to make it go more forwards, and negative is to make it go more backwards. So if it was creeping slightly, you add an offset and then you update the offset in there, which once again sends it to EEPROM. Similarly, if you want to, you can use the actual pulse readings instead of using the offset, but unless you know what you're doing, I would recommend that you don't touch the pulse settings down here. You can just manipulate the offset and then update it from there. Similarly, sometimes we'll set all of this up for you during manufacture, but sometimes different servos, the motor driver might go the wrong way when you tell it to go forward, and you can toggle it to reverse it, which is what's going on here down the bottom, and then that can be saved to EEPROM. So if you hit the forward button here and one of the servo's wheel motors is going backwards when you've told it to go forwards, which is obviously what the case was for the right-hand motor here, we just selected reverse, and then that reverses it in the motor driver and takes care of it. And then once again, it remembers that, so that when you go into scratch, it all works perfectly for you. Okay, great. So that's all of the outputs, the LEDs, the wheel motors, and the claws. The only thing we can't test in the eBot is the LED matrix. That can only be tested in MakeBlock. Thanks for watching.